Greetings to video 3. Now, so far we've seen, very promising news. As we can see here, the classification summary that the machine is, or the discriminant function was over 90% accurate in knowing what fake news was, and 96% accurate in understanding and recognizing real news. Which means that if you see something that's real news, our function is going to be right 90% of the time in saying that's real. And if you see fake news, it's going to be 90% right in calling it fake, but there are many errors it's going to make in thinking it's real at least 10% of the time. But we may be a little bit too optimistic, just a little, because when we put in cross-validation, which is a more unbiased measure, and actually makes the fit with the data more of an achievement than without cross-validation, our accuracy goes down very, very slightly for real news, where we just go to 96%. But it goes down below 90% for fake news, 887. Still very good, 88.7% correct, but it's below 90. So in the overall box score, when we didn't see cross-validation, of the 900 texts we had, because we had 450 fake news, 450 real news, out of 900, we were correct overall 841% of the time, which is a whoppingly good 93% accuracy. When we go down to cross-validation, where we lose about 10 corrective points from 841 correct to 831 correct, and so now we lose 1% of accuracy, but still very, very accurate, 92%. So now what I want to say is I want you to focus on, and this video is really to get you to focus on the linear discriminant function. This is really a mathematical equation, but for humanists. So Minitab just tabularizes it for you so that you can see. And what you're looking at here is the actual equation and the coefficients of the equation, or the weights, so assigned with each of the major variables. So what this means is, and the way to read this is that you look at the two numbers associated with fake news and Reuters news. And for academic language, for example, you'll see the number here for real news is 1.39 or almost 1.4. And the number for academic for fake news is just 0.5. So the point is that the Reuters number is much bigger, or at least considerably bigger, for academic news. The academic variable is higher for real news than for fake news, which means that the more an article has academic language, the more likely our machine is to say that's real news. Okay. If we look at character, which indicates people, on the other hand, you see that the Reuters number is 0.35 or 36 if we round it off, 0.36, but it's actually higher, 0.559 for character. That means that because character is higher for fake news, the more a story contains information about people or characters or pronouns or proper names, the slight weighting goes to calling it fake. So what the mathematical formulas have done for us is to create a very complex formula, because you should think of each of these variables as a recipe ingredient. And so to make fake news, you have to take all of these language ingredients and add these weights. And in order to make real news, you take the same ingredients, but you add the weights on the right. And that works very well for prediction, but the challenge we have as humanists is to explain it. So in the next video, I'm going to talk about how you can manipulate the linear discriminant function so that you can get more precisely at explaining what's going on, or at least trying to explain what's going on. So that will be the next